can't catch me if I run.
Mr. Quiroz has boxes in which he stores calculus books in. Mr. Quiroz has asked his students to return his calculus books for inventory. On the day he asked to return the calculus books, he receives them at a rate of 1 book every 30 minutes. Given that the relationship between the box's width and the height is equal to W is equal to 3.97 H, and the box's volume is 33,035.0042 centimeters cubed, find the rate of change for the volume in terms of centimeters cubed per minute, and the rate of change for the length, width, and height of the box given that the calculus book's relationship between width and height is modeled by W is equal to L height, and volume is 27,000.48. Also, for our hypothesis, we said that the volume of the calculus book and its length, width, and height should be equal to the rate of change to the volume of the box and its length, width, and height due to the space within the box being replaced by the calculus book. This empty box represents the available space that is in the volume of the box. So, when we add a book to the box, the volume of this book reduces the volume of the box. So, every time a book is added every 30 minutes, the volume of the box is reduced.
Whatever, go. So
See you guys.
the derivative, the rate of change for the volume is going to be equal to the volume of the book, and the rate of change for the length, width, and height are respectively going to be the dimensions for the book. So right here we have the equation for the volume of the book, which is equal to 2,700.48 centimeters cubed, which is equal to length times width times height. But when we replace it with the relationship for width, we get length times 6h times height, or 6h squared times L. We can then solve for L by using the surface area of the book, which is equal to 2L plus 2W plus 2H. When we simplify, we get that the length is equal to negative 7H. So using this as a variable, we can replace L in our original equation for volume with negative 7H, and we can simplify the variable equivalent to the book volume to negative 42H cubed. We can then solve for H by dividing 42 by 2700.48, and we get 64.29, which we then cube on both sides, and we get 3.95. It would be negative, but since the dimensions can't be in negative centimeters, we just round it to positive, and this is going to be, the height is going to be equal to 3.95. So after finding what h is equal to, we can then put it in for our equation for length, which is negative 7 times 3.95, which we get our estimated length is about 27.65. Again, length can't be negative, so we just make the equation positive, and that equals 27.65 centimeters per minute, which is going to be equal to our rate of change for the length of the box every 30 minutes. So on the board, our equation for width was wrong. This is the actual relationship for width for the book. The width is equal to 6 times the height. So when we put in our equation, when we put in our variable for height, which is 3.95, we multiply it by 6, and we get that the width for the book should be about 23.7 centimeters, which in relation to the volume should be about 23.7 centimeters per 30 minutes. And that's it.
After we measured the dimensions of the book, we found that the calculations we made that for the book, the dimensions of the book, were actually slightly off from the actual book measurements.
After mathematically solving for the rate of change for the dimensions of the box, we found that while we were correct in our assumption that the calculus book's volume, length, width, and height were the rate of change in centimeters every 30 minutes for the dimensions of the box were correct, our calculations were slightly off from the actual measurements. The dimensions for the rate of change for the volume of the box was equal to the volume of the calculus book, which was 2,700.48 centimeters cubed every 30 minutes. The rate of change for the height was 3.95 centimeters every 30 minutes. The rate of change for the length was 27.65 centimeters every 30 minutes. And the rate of change for the width was 23.7 centimeters every 30 minutes.